All right, in these notes, we're going to take a look at an introduction of what energy is, and it's actually in particular heat energy. So in the activity you did the other day, remember you had a quarter and a bottle cap, and you were picking them up to feel which one, quote unquote, felt colder, right? And we said that the quarter felt colder, and we had some ideas about maybe why it would feel colder. Well, here's what we actually concluded, right? So why do things feel cold? Like the quarter felt cold? Well, it's because it's sucking heat energy out of your hand. So if you feel an object being cold, you're actually losing heat to the object. All right, heat is going from you to the object. And so if heat is being lost, that means the molecules in your body or your hand are slowing down. And so if that's the case, then it's going to feel cold. Okay? So we also saw or concluded that because the quarter is made of metal, that metal objects were better conductors of heat. So they transmitted heat faster than other materials. So in the case of the quarter, the metal transferred the heat faster from your hand into it than the plastic bottle cap did. All right, so much like diffusion and osmosis that you've talked about and learned about in biology, heat energy flows from high temperatures to low temperatures. Just like diffusion, things move from high concentration to low concentration. It's always kind of a pattern in nature that anything that flows is going to go from high concentration to low concentration. So if we're talking about heat, heat is going to flow from high temperature objects, which is high concentration of heat, to low concentration of heat, or low temperature objects. So this is going to happen, this heat flow is going to happen from high to low, from hot over to cold, until both objects have reached the same temperature. Once both objects have reached the same temperature, we call that thermal equilibrium, and now there's no difference between which one's colder and which one's hotter because they're the same. So that's when heat flow stops, is when the two objects are at what we call thermal equilibrium. So bottom line is heat flows from hot to cold until you get to thermal equilibrium, or when both objects are the same exact temperature. So when you're thinking about it in terms of the quarter, right? So if you hold the quarter in your hand long enough, all right, the heat is going to stop going from your hand into the quarter because the quarter will now be the same temperature as your hand. And so it will no longer feel colder to you. It will feel like the same. Okay? So that's another way to kind of think and visualize how this is going to work. Heat moves from hot to cold. Okay, so hopefully it's a little obvious, but if not, we're just going to go over it. So when objects lose heat, their temperature is going to drop. The object's temperature is going to drop when it loses heat. Okay. Similarly, when an object gains heat, their temperature rises. Right. So when you lose heat, you are transferring heat away from the object. Then that means the molecules in that object are going to move slower because they have less energy. And so if that's the case, then their temperature starts to drop, because remember, temperature is a gauge of how much the molecules are moving. Now, when an object gains heat, the temperature starts to rise, because now the object's molecules are moving much faster. So that means their temperature is going to go up. All right, so let's take a look at some examples of heat flow and energy. And talk about it in terms of movement of heat, and then also what happens to the temperature of basically the temperature of the object. So example number 1, what happens when a 25-degree object comes in contact with a 0-degree object? So let's just say that this beaker here is 25 degrees Celsius and this one over here is 0 degrees Celsius. All right, if we were to put them right next to each other, all right, or pour one into the other, okay, what's going to happen? Well, we just found out in the last slide that that heat is going to move from the high temperature to the low temperature, right? So heat flows from hot to cold, and it's going to do that until they become the same temperature, right? So we'll put until same temperature. Okay, so it's going to move from the heat is going to move from the 25-degree object to the 0-degree object until they reach the same temperature. Now, as heat flows, right, the solution that's 25 degrees Celsius is going to start to decrease in temperature, okay, because it is losing heat. However, the 0-degree Celsius one, that one is going to start to increase in temperature because it is gaining heat, okay, from the other solution. So we're going to see a temperature drop in the 25-degree solution, and we're going to see a temperature rise in the 0-degree solution until they reach the same temperature, thermal equilibrium, right? Okay, so next scenario to think about is, what if two 100-degree objects come in contact with each other? So what if we had, this block that was 100 degrees Celsius, and we had this block right next to it that was 100 degrees Celsius? Okay. Well, if we think about it, if they're the same temperature, is any heat going to flow? Okay, the answer is no. We're not going to get any heat flow. Because they are the same temperature, they are at thermal equilibrium already. Okay, so they're at thermal equilibrium. So no heat flow is going to happen in this particular example, because they're both at the same temperature. They're both at thermal equilibrium. And once two objects reach thermal equilibrium, there's no more flow of energy. All right, so we alluded to this during the activity that we were doing, the Caliente Frio activity. At the very end, we had talked about the difference between exothermic and endothermic. So now we're going to put them, the formal definitions and notes in the notes of your notebook. So when an object's temperature drops, that means it's transferring heat to the environment, right? So if it's giving away heat, it's transferring it to an environment. We call that exothermic. This is called an exothermic process. So here is an example. This is a red hot solution of liquid, okay? And because it is losing heat to the environment around it, okay, we call that exothermic. Okay, now if you put your hand right next to it, it's gonna feel hot because it's releasing energy to its surroundings. And if you happen to be the surrounding, then it's gonna be releasing energy to you. So that means your molecules in your hand are gonna start to move faster. If they start to move faster, it's gonna feel hot. All right, so as this object is radiating heat, right, its temperature, its core temperature inside is actually dropping, okay, because the heat is being released. So the temperature will slowly drop as the heat is being released to the environment. And again, we call that an exothermic process. And it's going to feel hot. Exothermic processes always feel hot. Think about a fire. A fire is an exothermic process. It's wood that's burning that's releasing heat to the environment. And if you stand right next to a fire, guess what? You're the surrounding environment, so you are going to get that heat that's being released, and it's going to feel hot to you. All right, so on the other hand, if an object is gaining heat from the environment, if it's absorbing heat from the environment, so think about the ice cube question in the ice cube demo that we had in the activity, right? As ice is melting, it has to absorb heat from the environment. We call that an endothermic process because heat energy goes in, endo meaning in. So heat energy goes in, right? So if heat is being absorbed or going into a solution like this one, okay, then it's going to be, and if you put your hand next to it, then you're the surrounding environment where it's getting heat. And so it's going to be absorbing or taking your heat from you. And so that's why it feels cold, okay? Because it's stealing your heat, just like we had said at the beginning of this video lecture, right? So just like the ice cube, if you hold the ice cube in your hand, it feels cold. Why? Because it's absorbing the heat from you. It's transferring heat from you into it in order to melt it. And so if it's taking heat from the environment, it is an endothermic process. All right, so I hope that is a clear intro of what heat energy is and how it transfers from one object to another, and then the difference between exothermic and endothermic. We're going to continue our journey of studying heat, as we are going to actually quantify heat and figure out how we calculate the heat given off by an object. And that's going to take place in our next lab. All right, so that's it for now.